Okay, today's lesson we will continue our conversation on types of forces. We're going to talk a little bit about friction and tension. All right. When an object is in contact with the surface, there is a force acting on that object. So obviously, if an object is sitting on a desk, there's a force between the desk and that object. The component of the force that is parallel to the surface is called the frictional force. And friction is the force that opposes motion or the start of motion. There's two types of surface friction. The first is static, and the second one we'll talk about is kinetic friction. When we have two surfaces that are not sliding across one another, the friction is called static friction. For example, we have a block sitting on a ramp. There's nothing holding it there other than the force of friction. If there was no friction, it would slide down the ramp. So static friction is due to what's called cold welding, or surface adhesion. It's caused by the intermolecular attraction between two objects. So if you look at this, if you take a blow-up of two objects in contact, if you look at it microscopically, a really, really small picture of it, you'll see that there will actually be molecules that are actually really close to touching each other. And this interaction between these two is what holds it or sticks it together. It's called cold welding. Kinetic friction is a force of friction exerted on moving objects. For example, if you move this block, well, that was loud, you would get kinetic friction, and the object has to be moving for kinetic friction. So what type of friction is greater, static friction or kinetic? Well, static friction will always match what you apply to it until some maximum value, then it can't do it anymore and it breaks away. An example I would like to try with you now is if you take a book and put it on your desk or the table, wherever you're watching this video, and gently, very, very gently push on the side of it. Don't cause it to move, but just gradually increase the pressure until all of a sudden it moves. If you do it correctly, you'll feel it almost like match what you're pushing with, but all of a sudden it jumps. And this is because the static friction is greater than the kinetic friction. So it can hold it better in place, but once it can't hold it anymore and lets go, this kinetic friction is actually lower. And in conclusion, basically, the maximum static friction is greater than kinetic friction. And here's a little graph that may help you understand this. Okay, so as you were pushing on the book, it was matching your push. Kept on matching it until it couldn't do it anymore and it jumped, it skipped. And then the friction force was less. So the static friction can be greater than the kinetic friction. Okay, now I'd like to talk to you about what's called the coefficient of friction. The coefficient of friction is just a ratio of the force of friction, in other words, how much you're pushing on the side of the block to get it to move, compared to the normal force, and that's the interaction between the surface and the block itself. And there's a ratio between the two, and it's called the coefficient of friction. And there's one for static friction, there's one for kinetic. Let's look at the kinetic one. The force of friction, kinetic, is equal to mu force normal. Alright, so let's look at it a little bit simpler than that. Let's look at what mu actually is. Mu is a ratio of how much you have to push over compared to how much the table is pushing back up on a box. So in other words, you were pushing your notebook before. The force of friction, kinetic friction, is how much you have to push over compared to how much the table is pushing up on it. And there's a whole bunch of different coefficients of friction depending on what the material is. For example, glass on glass, you have two different coefficients of friction, one static, one kinetic. As you can see, the static is always going to be greater than the kinetic. And there's some things that are very, very easy to slide, like Teflon. You can see it's so much lower than glass on glass. So what affects friction? Obviously, the two surfaces in contact. Some materials are more slippery than others. Steel on steel has a different value than steel on copper. Each combination of materials have their own unique value of slipperiness. And obviously we can't use slipperiness, but the scientific word for that is coefficient of friction. But it's really just how slippery they are, the two surfaces. So how can you reduce frictional forces? Well, you can oil or lubricate them. And if you're oil or lubricating them, really what's happening is you have two surfaces that are no longer riding on each other, but they're riding on the lubricant. You can smooth the surfaces so there's less interaction between the two objects. But ironically, if you polish them too much, you'll actually increase static friction. And I wonder if you can figure out why. So if you reduce this so there's more points in contact, why would you actually increase static friction? And the answer is cold welding, because you'll give more points of contact for cold welding. All right, so let's give this an example. You have a sled that's moving at 4 meters per second comes to a stop. So obviously the frictional force is acting in the opposite direction of motion. The weight is acting down, the normal force is acting up. And we understand from Newton's third law that these two have to be equal and opposite. And Newton's second law, weight is equal to mass times gravity, or force is equal to mass times acceleration. So if we take the same example, this time putting some numbers in, suppose the coefficient of friction is 0.05, and it's going to be pretty small because you're talking a plastic sled and snow, so that's pretty slippery. And the total mass of the sled and child is 40 kilograms. What's the kinetic frictional force? Well, force of friction is equal to mu force normal, mu times mg, which is the force normal on a surface where they're both perpendicular to each other. And then you get, putting the numbers in, you get 20 newtons. So it's a pretty easy calculation to do. All right. Let's look at an object on a ramp, because this is kind of interesting. You have weight acting straight down, and we can break that weight into two components. One acting along the y, so we'll call it weight in the y, and one acting along the x, we'll call it weight in the x. And we know that the weight in the y has to equal the normal force, and we know that the weight in the x is equal to the frictional force. This is assuming that the two are not moving, or moving with a constant velocity. All right. If we know this, then we can actually calculate what this weight in the y is and weight in the x is. Weight in the x would be mg sine of the angle. So weight in the x, if this is the angle, the opposite side would be the sine. So it would be mg sine. Mg, because of the weight, is mg. Sine, because it's the opposite. And that would be equal to the force of friction, because the weight in the x is equal to the force of friction. And weight in the y would be mg cosine of the angle, and that has to be equal to the normal force. Okay? So let's see if we can figure out what we could do with that. I'm just copying that down from before. Now I know the force of friction, or the force of friction static between the two surfaces is equal to mu force normal. Okay, or mu normal is equal to force of friction divided by the force normal. So if I take these numbers and plug it in over here, I get an interesting result. So you can take the mg sine of the angle, mg cosine of the angle. This ends up being the force of friction. This ends up being the force normal. And sine divided by cosine ends up being tangent, and the mg's cancel out. So what does this tell you? How do you actually figure out these coefficients of friction? It's actually pretty simple. You just put the object on a ramp, and as you lift the ramp, where it starts sliding, you measure that angle, and that's the coefficient of friction between the two surfaces, the ramp and whatever's sliding down it. Okay, now we're going to talk a little bit about tension forces. Cables of rope transmit forces through what's called tensions. So for example, you have an object here, You could pull on the object directly, or you could pull on it with a rope. Either way, it's going to be the same force. This force here is equal to the same force that acts on the object. And the rope itself feels you pulling this way with some tension, and it's pulling back this way with some other tension. The object is pulling back on it. Let me try to say that a different way. The box is pulling back on it with a negative tension. All right, so let's say you have an object that you're lifting with a rope and a pulley. We're going to assume that the rope is massless, and will transmit the tension undiminished from one end to the other. In other words, there's no difference in the tension here compared to here. If the rope passes around a massless, frictionless pulley, the tension will be transmitted to the other end of the rope, undiminished. So basically, if you look at this, if this thing weighs 100 pounds, he has to pull down with 100 pounds. So the question arises, why the heck would he use the pulley in the first place? And really the only reason he would be using this type of pulley is because he's changing the direction. He pulls down with 100 pounds, the block that is 100 pounds goes up. And that's just a little bit of talk about friction and tension. And in the next video, we'll talk more about how to actually use all these types of forces to solve problems.